So everyone, I'm Riccardo Magliocchetti, as you may already know now. I work on observability at Elastic, where I maintain our Elastic distribution of OpenTelemetry Python, which is OpenTelemetry Python distribution. And I'm also a maintainer for the upstream OpenTelemetry Python project. In this talk, I want to show you how to add observability to a Python application with OpenTelemetry, but without touching the application code. This kind of instrumentation is also known as autoinstrumentation or zero-code instrumentation. So the agenda for today is, first, we'll take a look at the OpenTelemetry Kubernetes operator. That is a Kubernetes operator to manage an OpenTelemetry collector instance and to inject auto-instrumentation into to your pods. Then we'll take a look at OpenTelemetry Python own auto-instrumentation solution that is based on the OpenTelemetry-instrument wrapper. Then we'll take a brief look on how to add auto-instrumentation programmatically with 2 lines of code. I know it's not actually zero code, but 2 lines is short enough. Finally, we'll take a look at the GenAI work we are doing inside OpenTelemetry, especially in OpenTelemetry Python. So, I'll start by giving to people that are new to observability or OpenTelemetry space a bit more context. Please note, this is not an OpenTelemetry tutorial. I think she already asked the question, but how many of you know OpenTelemetry? Okay, more people than before. And how many of you are using it in production? Okay, doesn't hands, so cool. So, observability is the ability to understand the internal state of a system by examining its outputs. This means being able to understand a software system by looking at the telemetry data it exports. In other words, unless you have a crystal ball, like you need data, to have a clue on what and how our servicing are doing. OpenTelemetry is an observability framework providing both specification and implementations, and in order to create and manage telemetry data. It is a CNCF incubating project, and the telemetry data it manages are traces. Think of like requests or calls into your application, like spans of time of doing work like database calls, HTTP calls, RPC calls, stuff like that. And then we have metrics to capture some measurement at runtime. For example, memory usage, time spent serving request, number of tokens used in GenAI system, stuff like that. And then we have logs that are some structured or unstructured text with a timestamp. You may already familiar with that. Last, we have another thing that is profiles for collecting profiling data. And in OpenTelemetry, these kinds of data are called signals. And mind that profile signal is not stable yet, but there is a lot of work going on. So the output of this thing should be something like this, like something in this picture. This is like an example of tracing. We can see like 3 services, one in green, and the other 2 in blue and red here in the bottom. You can see like this waterfall view, where you can see like the dependencies between your services and the actual work being done. And then like metrics look something like this. In this chart, we have like just a couple of metrics about the CPU usage, like nothing fancy. Logs may look something like this. In this screenshot, this is a screenshot of some logs from the OpenTelemetry demo, and we are filtering logs from the recommendation service. The OpenTelemetry demo, by the way, is a demo project where you have like a bunch of services, like creating data in different languages, and so you can see like how instrumentation work, what data you can get from the services. Yeah, if you are in DevOps or Ops space, you're probably like used to something similar. Now, enough for the introduction. Let's look at the option we have to actually like observe our Python applications with OpenTelemetry. I will start with the OpenTelemetry Kubernetes operator. The OpenTelemetry operator consists, of course, of a Kubernetes operator, but manages a couple of things. First, it manages an OpenTelemetry collector instance, and the OpenTelemetry collector is an implementation on how to receive, process, and export telemetry data in various formats. Of course, it supports the default OpenTelemetry OTLP protocol, but it also supports Prometheus and Jaeger. The operator also manages a system to inject autoinstrumentation for a bunch of supported languages, Python included. For Python, this works by copying the Python OpenTelemetry code to a volume, then mounted to your application pods. Then the operator is also setting some environmental variables that are required by the OpenTelemetry Python agent to work. But this is everything done under the hood. This managed OpenTelemetry collector instance, while being optional, is advised because it lets you simplify like a bunch of things by acting like as a proxy between your Kubernetes cluster and the platform where we store your data. First, it simplifies the management of secrets, where like only the collector will know like the secrets necessary to access your observability platform. And then your application can just export inside the cluster to the local collector. And also the collector is handy place to do some processing of telemetry data, like you want to do filtering, some sampling, like maybe just adding or deleting attributes, renaming metrics, and a lot more. I left like a link where you can find more information about that. In the last months, there have been a few nice improvements regarding the Python auto-instrumentation from the OpenTelemetry operator. First, like more environment variables are set by default, so you don't have to set them anymore. And like by default, it works out of the box now. And then we had the support for muzzle-based container images, like the Alpine one. And please note, this work like also enabled improvements to the wider Python ecosystem, because now we have like binary wheels for ARM64 for muzzle of the gRPC IO package. But it's like the package implementing gRPC for Python. This is a big deal because it used to take like tens of minutes in CI, at least for me, when building images. So nice. Okay, now let's look at some YAML, because like we are at the DevOps conference after all. Here's a toy manifest where like for the OpenTelemetry collector configuration, like the interesting bits in, I think it's light blue, but looks more green there. We set up 2 endpoints as a receiver, that is like the entry point for the telemetry we are accepting. So we have the gRPC based one on port 4317 and the HTTP protobuf one on 4318. And by the way, the HTTP one is the default from the operator Python instrumentation. But on the other hand, the Python own auto instrumentation uses gRPC by default. The other thing is, this is why this is like a toy implementation. Here we are just like the debug as exporter. Like in production, you probably have something else like forwarding to another observability platform doing the ingestion, or maybe just like sending to a database or stuff like that. And here we are just a debug, so like if you run this, we see just some logs of the stuff it receives. And then we set up the instrumentation resource for Python services. The interesting bit is here, but we are referencing the local collector we have set up in the previous YAML on port 4318. Then this is deployment manifest for our application. In our application, we have like to enhance our YAML and add something like this metadata here. These are like a couple of annotations. The first one, we are saying just like we want to inject Python using the, in this case, Python instrumentation name, that is the name of the instrumentation we have seen in the YAML before. And also, this is just an example. We are setting, like we're saying that our Python image will use an image based on the Muzzle C library. By default, it's glibc. But yeah, like if you use glibc based image, you don't have to specify anything because it's default. Okay, now to the bad parts. Currently, there is just one OpenTelemetry operator Python auto-instrumentation image built per operator version. And this image is built for a single Python version, but contains both the glibc and the Muzzle instrumentation builds. The problem is that this is built with a single version of Python, and we have two problems actually. The first problem is that some Python packages ships with some binary code. And this is the case like for the gRPC-IO package we've seen before, but also for the PSUT package, that is the library that is powering OpenTelemetry Python instrumentation for system and process metrics. And on Python, these binary extensions are tied, of course, to a specific C library, but also to a specific Python version. And so, like on the Python side, we also had like to update our agent code to be more lenient about these issues. Because like if Python does not like how the binary code is built, it will just not load and fail an import usually. And the second problem is not only like the platform and the Python version, but it's also that some packages may not support all Python version. And so if you are built, if the image is built for a Python version that is newer than the one you're using in your containers, it may be that some of the stuff already installed there will not work on your Python version. For example, recently we had like an issue where a person was using Python 3.8 images, and since it's not supported anymore upstream, libraries already started to remove support for it, and so it didn't work. And the workaround was to like not use the latest version of its dependencies, but is URL lib free, if you're curious. Okay, so the solution for the issue is simple, maybe a bit annoying, and it's simply that just you have to build your own image if the one provided by default does not work. And yeah, this is like the updated manifest. I've just added a specific Python image. Like it's of course your image, it's a random string. Okay. This was the Kubernetes parts, the first option. We have to run, to auto-instrument our Python code. And the second option is to use the OpenTelemetry instrument wrapper as shipped by OpenTelemetry instrumentation package. So, OpenTelemetry instrument is the tool we are using, and it's just like a Python command that is doing like some Python tricks under the hood in order to set up and load all the SDK and the Python agent code before your application. And we see like a little example of a recipe for Docker container. This is taken from the Elastic distribution of OpenTelemetry Python because it's more handy for me to show it. And The interesting part are that here we are using like this tool called IDI.bootstrap, but it's like just a customized version of the upstream OpenTelemetry Bootstrap. And it is a tool that scans your environment, looks for libraries that we have instrumentation for. And with this -a install parameters, it just install the needed instrumentation it can find. And then here, this is how opentelemetry-instrument work, and it's just like a wrapper for your command. In this example, it's just a Flask run, which of course is like, you shouldn't use this in production, but it is fine for an example. Now, in order to run this thing, you need like a couple of variables at least. And yeah, this is like a reducted example where we are setting like the endpoint of the OTLP receiver, where we are sending our data, and also some headers where like we are sending the authentication for that endpoint. And by the way, if you're using like a local collector with the gRPC receiver without authentication, you can skip these two parameters because it will work out of the box. Okay, if you're interested in how the Python OpenTelemetry agent work under the hood, I've done another talk. You can find like slides and the video in the link, because I don't think it's many of you are Python developers. Wow, I haven't asked that. How many are Python developers there? Okay, a third of the room, nice. Okay, third option for auto-instrumentation Python application. This is like programmatic, so it requires some code, but it's just like one line for import and one line for calling the setup code. So yeah, this is like has been added to the latest release from like last Wednesday, which is like 2 days ago. And yeah, just through Linux code. But this still relies on environment variables for configuration, because it doesn't have like any entry points otherwise. So, recap, what we should use. Like, as always, it depends. If you're using Kubernetes, of course, the operator may be your first choice, because you don't have to touch application code. You have just to provide like some YAML. And just remember that you may need to build some custom instrumentation images if you're if the Python version of the instrumentation code does not match one of your containers. Otherwise, second option, there's the OpenTelemetry-instrument to wrap your application entry point still without having to touch your application code. And the first option, you can have also programmatic auto-instrumentation, which requires just 2 lines of code to change. And yeah, it still relies on environmental variables for configuration. And like this last third option may be used in environment like something like Jupyter notebooks or stuff like that, where like you don't have control of where you run your application. And okay, this is the part from the for the auto-instrumentation. Now we'll take a quick look on observability of GenAI application with OpenTelemetry. Just another question: how many of you need to instrument or observe GenAI a Python application? Okay, couple of hands. Okay, 3. Okay, nice. Okay, so there are 2 kinds of work we are doing inside of telemetry regarding GenAI. First one is writing some semantic convention. Semantic convention are like specification of what the output of tracing metrics and events should be logged. And yeah, so it's just like writing specs. And then, of course, the other part of the work is like writing actual instrumentation for new libraries. And of course, like when you do like the actual work, you see like maybe difference or something that you haven't planned for in the specification. And so, yeah, you know, one work influence the other. At the moment, for the GenAI semantic convention, we define like span attributes for tracing chat completion API calls, but is like the usual way where you interact with LLMs. And then we also have span attributes for embeddings API calls, but is like when you send to the LLM, well, to the model some words and you get a vector of numbers in return. Like this is a screenshot, yeah, where like just to show like some of these attributes, like we have the model names. This is so small. I need to. Okay, model names, the provider. This is like an example from calling a Qwen model locally using the OpenAI library. The Qwen model was running inside Oyama or Olama, I don't know how it's pronounced, to like provide a compatible OpenAI API. Now, we also have a bunch of events for the various messages using in these GenAI chat sessions. We have, of course, event sets for the various message roles like system user assistant, developer, for stuff like that. And then we have an event for responses where we got from tool calls. I don't know if you know what are tool calls. Tool calls are, you know, when you can use some external code and you ask the model just to provide a way to call them, like which parameters to send them, an ID. And when you call on your own this tool code, which is like function or external services, stuff like that, you pass back the responses to the model with the IDs, and so it's able to to understand where this data come from, and then it'll give you an answer. And then we also like an event, of course, for the model response, and this is called the choice event. Here is an example. This is like again some choice events from OpenAI. Yeah, not interesting. If it's just like the biggest part of the response is just the content, the actual response, which is some random stuff. And then we define a couple of metrics. First one is the duration of the operation. What is the time to get a response from the models, of course. And then we also track the number of tokens, both the input and the output tokens, which is like the stuff you usually pay. Yeah, nothing earth-shattering here. This is just like some metrics about some calls against the API.OpenAI host. Again, we are tracing like the duration in red and the tokens in blue. Okay, on the pattern side, we have just a bunch of instrumentation. We have the OpenAI, but support like most of the common APIs. At Elastic, we also have ours, that also supports tracing embeddings calls. Please note with the OpenAI library, you can talk to other APIs like Mistral, Anthropic, and DeepSeek, at least. So like it's not limited to OpenAI models. When we instrument libraries, we are like instrumenting libraries and not, platforms. And also we have a pretty complete AWS Bedrock runtime API. Yeah, the 4 main entry points that AWS provides. Yeah, unfortunately, like the invoke model APIs from AWS are like a really thin layers over models, and so like we don't abstract anything. And so like we had the support for just a bunch of models, namely the Amazon Titan and Nova and Anthropic Cloud. And so like for tracing other models, it will require some work. We have also have Google Vertex AI instrumentation, and in the works there is a Google GenAI instrumentation. What's next? Finish the missing bits of this instrumentation, create other instrumentation. But also, like there is a donation proposal from the OpenLLM OpenTelemetry project. And so yeah, it's still like in the works. If the donation will be accepted, we'll get like a bit more instrumentation to like update to the OpenTelemetry upstream GenAI semantic convention. Yeah, of course, like big topics right now is agents. That is like, if you remember like the example of the toolkits before, it's just like giving the permission to the models to do the call on its own. And yeah, we are working on semantic convention, and we are looking at the invoke agent semantic convention right now. So to conclude, you have a bunch of options, like you can use the OpenTelemetry operator for Kubernetes. You can use the Python agent on OpenTelemetry instrument to wrap your application. Also, like if you don't have any other options, you can use a couple of lines of Python code with the programmatic auto-instrumentation. And yeah, we are working on GenAI instrumentation. Left here some references and contacts, just some website and GitHub repos. Also, like if you're interested in OpenTelemetry, there are channel on the CNCF Slack. Yeah, my contact, and I share the slide on speaker deck. And that's it. Thank you.